Hello friends, in this video we are going to see what are some of the reliable and unreliable communication protocols. And when we are talking about reliability, we essentially mean that a way of communication in which a sender knows or he is assured that the data that it delivered or sent to the receiver was received by that particular host. So what I mean by that is that, let's say if we have a box over here, could be Linux or any other box, and maybe this is another box and this is connected via some medium, could be internet as well. So host A or station A and station B, and host A sends a packet to host B. Now host A does not know that whether the packet has been received by B or not until and unless B sends back some kind of acknowledgement, isn't it? So only then A would come to know that whatever he had sent earlier has been received by B successfully. Now there is a protocol which is TCP or Transmission Control Protocol, which works on OSI layer 4 or TCP IP model layer 4. Now how TCP established that? Well, if you look at the TCP protocol header, then besides other fields, there is a field which is sequence numbers and acknowledgement numbers. So when a packet is sent by a host A to host B, then host A inserts a sequence number in the sequence number field and sends the packet out onto B. Now when host B receives that packet, it looks at the sequence number and sends back the acknowledgement to A. So A knows that whatever packet he had sent earlier has been received successfully by B. Not only that TCP provides this sequencing number, it also provides a phase which is we call it three-way handshake. And what it essentially means that before any data is sent, any user data is sent between two end terminals, a connection establishment phase is processed. And what is that? Is that if A wants to send data to B, then first it sends a sync packet, SYN sync packet, and B sends back a reply to that sync packet, and it sets the flag in that sync packet in TCP fields, which are sync and ACK. Now this is the second packet of this three-way handshake. The third packet is sent again by host A, which is ACK or acknowledged. Now once these three packets are exchanged successfully between host A and B, then actual data transfer gets started. So not only that TCP is a reliable communication protocol, but it is also connection oriented, that first a connection has to be established before data could be sent out. Now this TCP protocol, it is very much necessary as of today's communication. If we have got low speed links, like back in old days we had modems and modems which used to connect on 56 kbps speed. These were dial-up modems, and when we used to dial to ISP, we used to listen to these musical sounds like no, and then there was some beeps until unless modems got answered from the ISP side, and then they got connected. So at that time, if you had a 34 kbps connection, it would have been considered pretty good considering the quality of the telephone lines. But now we have got DSLs which provide up till 54 Mbps. So consider that in a network where your computer is trying to connect to the internet and getting information from the internet, it might be going from a series of links which may not have the same capacity throughout the path. For example, it could be your DSL of let's say 30 Mbps, and then in between the internet core, it could be gigabit or maybe even terabit links. And then on the other end, it could be a low end pipe, maybe 5 Mbps. So you see that throughout the path, the speed variation would be there. So if there are any chances of link congestion on the other end and the packets gets dropped and acknowledgements are not received to the sender, then A will send or the sender will send back the package that it had not got the acknowledgement for. So in case you are kind of accessing your bank account information, or you are sending or receiving emails and a packet get lost, and that packet may have some credible information in it, then be assured that if it's a TCP based if it's a TCP based communication, then that packet will again be sent by the sender, or in case of let's say your email, then the email server will send that packet back to you unless you acknowledge it. On the other hand, we have another protocol which is UDP, or user datagram protocol. This protocol also works on layer 4 of the OSI or TCP IP model, and in contrast to TCP, it does not have these field sequence numbers and acknowledgement numbers in its header. So it does not provide that reliability feature, but resulting in because of the short header, it provides us the fast communication. What it does is that as soon as sender A wants to send data to B, it just starts pumping the data without waiting for the acknowledgement. So in case of UDP to work efficiently, we must have reliable links in between. Usually this UDP, this is used for multicast purposes. So multicasting is the main feature or the main application that implies UDP, because multicast is like we have got one speaker. So let me just try to draw this figure. So we have got one speaker and there are several listeners, just like radio broadcast or TV broadcast. Now once that broadcast is going on, then it really is not necessary that each and every receiver replies back. It does not work that way. Once the sender sends the information, it assumes that it has been received by the other end. Whether it is received or not, that is a separate story. But most of the time, the applications that use UDP protocol, what they do is that they send multiple copies of each packet, so that even if some of the packets gets dropped, the actual information gets received by the receiver. Now this is I mentioned that this is used in multicast, and one of the multicast application is VoIP, or voice over IP protocol. Now while we are talking about TCP or UDP, we cannot end our discussion without talking about the port numbers. So let me clear this slide and start with a blank one. So in TCP and UDP headers, you will also find a field which says port. Not only port destination, so port destination, but also source port. Now this port, you might assume that it's a physical port. Well, it's not a physical port. It's a logical port that identifies that what was the application. Pardon me, this was source one. So destination port and the source port. Now this identifies that what was the application that sent the packet and what is the application that is going to receive the packet. Now normally source ports are generated randomly. So whatever host has sent the packet, it generates a random port against that. But the destination port, that is the actual port which application is listening on. So let me just draw this quick figure. If we have got, let's say, maybe a terminal over here, this could be very well be a Linux workstation. And then we have a Linux server over here. This Linux server might be having a web service running on it. It is serving web pages. It might also be having FTP service running on it for putting on data, and as well as it could be running SSH for remote access. Now you see it must have got one IP address and it has got 3 applications running on it. When a packet is sent by Linux machine, or a workstation onto this one, then how does Linux machine could identify that which application it is directing its packet to? Well, that is the thing which is provided by port numbers. When it sends the packet, let's say for www, then in the port field it will mention port number 80, which is the logical number or the standard logical number for HTTP protocol. Hypertext Transfer Protocol logical number is 80. So once that packet on port 80, logical port 80 is received by this server over here, the server knows that it needs to send this packet for its web application, which could be an Apache server, or in case of Windows it could be an IIS server. Likewise, if a user over here starts his SSH session for remote accessing this server, it will send in a packet, a TCP based packet which is having a TCP port of 22 destination port, which corresponds to SSH. So once that packet is received by the server knows that looking at this port, this is an SSH traffic, and traffic will be handled or handed over to SSH protocol. So once that packet is received and is processed, the reply will be given back, and the destination port this time will be the source port that was originally set by the sending machine. So really in today's world, the source port is mostly generated randomly because sender does not need to have a specific port. The application is running on the receiver side where the sender wants to connect to, and not on the receiver side, or not on the sender side. Now there are some very common ports that you need to remember. For example, one I can see on top of my head is 20 and 21, which are for FTP. Port number 21 is for data traffic and 20 is for control traffic. Similarly, port 22 is for SSH, port 23 is for Telnet protocol. Then we have port number 25, which is for simple mail transfer protocol. We also have DNS port, which is both TCP and UDP, and its port number is 53, which is for DNS, and it works both on TCP and UDP. We also have HTTPS, which is secure HTTP, which works on port number 443. So this is HTTPS. And then we have POP3, which is for receiving the emails, which works on port number 110. We also have SNMP, which is also a well-known port of 161 and 162. So these both are used by SNMP protocol. Now let me bring up the terminal and show you what are some of the ports which are by default available that you can look into the configuration file, so that you know that what ports are available on Linux systems. And I also should mention over here that port number starting from 0 to port number 1024, usually this range is also called as well-known ports, and the upper range goes up till 65,535. Now you can also set your own ports, but try to set your ports out of these well-known ports, because these have been standardized, and not only these but way more than that have been standardized as well, some of them. But for generic purposes, we say that port number 0 to 1024, because most of the services, essential services like email, web, remote access, they have been put in this bracket. So here I am on my Ubuntu box, and over here if I type in, let's say more/etc and then services, then we see that we have got this echo, and if I bring it down, we see that we have got FTP service, which is running on port number 21. This is the control, and the actual data is transferred on port number 20. Similarly, we have SSH, we have got telnet, SNMP, name server, which is IN116. This one is different than the DNS entry that I told you about. Then we have domain. This is the DNS that I was talking about, domain name server. Then we have TKX, which is an authentication protocol. And we have got TFTP port number 69. And this one is important, HTTP. You should remember it by heart, that port 80 is used by HTTP protocol. Likewise, if we come down here, this is post office protocol, port number 110, and so on and so forth. Try to go through with this list. Not every service you need to remember by heart, but the ones that I mentioned earlier, at least you should know about them because they are used on daily basis. And a good system administrator should know those ports, and not only those but some other as well, by heart. So that's all there is to it as far as reliable and unreliable communication protocols are concerned. We have seen the working of TCP, we have seen the working of UDP, what are the advantages of TCP as compared to UDP, and in which situations UDP suits us better, where we had seen about the multicasting purposes. And we have also seen that how these protocols work based on the ports that are assigned to them, or their applications that are running on top of these protocols. So that's all for this video. I hope you have learned from this video, and I would like to thank you for viewing.